Good morning students. In this class we will see the three methods involved in numerical integration. What are the three methods we used in numerical integration is trapezoidal rule and Simpson's 1/3 rule and Simpson's 3/8 rule. The introduction of these three rules are given as the trapezoidal rule approximates the definite integral using the trapezoidal approximations. When we are going for two rules of Simpson's rule, these two rules approximates the definite integral by first approximating the original function using the piecewise quadratic function. When compared with all the other rules, this Simpson rule we can able to get the piecewise quadratic functions. These are the introductions of the three rules. Now we will see the formula of all the three rules, that is formula of trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule. The formula of trapezoidal rule is given by integral x0 to xn f of x dx is equal to h by 2 into sum of the first and the last ordinates plus 2 into sum of the remaining ordinates. This shows the formula of the trapezoidal rule. When we are going for Simpson's 1/3 rule, the formula is given as integral x0 to xn f of x dx is equal to h by 3 sum of the first and the last ordinates plus 2 into sum of the remaining odd ordinates plus 4 into sum of the even ordinates. This formula shows the Simpson's 1/3 formula. And when we are going for Simpson's 3/8 formula, it is given by x0 to xn f of x dx is equal to 3h by 8 into y0 plus yn plus 3 into y1 plus y2 plus y4 plus etc. plus yn minus 1 plus 2 into y3 plus y6 plus etc. plus yn. This shows the Simpson's 3/8 rule formula. Now we have seen all the three formulas of trapezoidal rule, Simpson's 1/3 and Simpson's 3/8. By using these three formula in a single problem, we can able to get the final result so that we can able to compare the result. We will see in the example clearly. Here they have given the example, that is to evaluate the integral 0 to 6 dx by 1 plus x square. By using this integration, we want to find the trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule. After calculating all these three rules, we can able to compare and analyze which method will be suitable for this function. In order to derive all the three formulas, we want to formulate the tabular column. Before formulating the tabular column, we want to find the interval length. Interval length is nothing but it is the subtraction of the upper limit to the lower limit. Here the upper limit is given by 6 and the lower limit is given by 0. So the subtraction of the upper limit minus lower limit, you will get the value to be 6. This shows the interval length. After that, we want to find the corresponding function into 6 intervals. By dividing this function to the 6 intervals, the formula is obtained by h is equal to b minus a divided by 6 is equal to b minus a is the interval length which we got already as 6 and divided by 6. If we divide these two values, we will get the value to be 1. This shows the interval of the given function. After finding the interval length, we want to formulate the tabular column. How to formulate the tabular column is we have seen already. That is, you want to write the x value. The x value must start from the lower limit and it must end with the upper limit. In this given problem, the lower limit is from 0 and the upper limit is found to be 6. So you want to start the tabular column with 0 and you want to add the each and every value with the h value. Here we got the h value to be 1. So the first value you want to add with the h value. So 0 plus 1 you will get 1. After that, from the second value you want to add the h value so that you can able to get the third value as 2. After that, getting the third value, you want to add once again the h value to get the fourth value. Likewise, the tabular column will extend until you get the upper limit. Here we got the upper limit as 6. So till you get the upper limit, you want to extend the tabular column. Once if you obtain the upper limit, then you can stop the tabular column. After finding the x value, you want to find the y value. Here the y value is given as the function, that is 1 divided by 1 plus x square. In this term, you want to substitute the corresponding x value. See, for the first term the corresponding x value is 0. So instead of x square, if you substitute the x to be 0, you will get the value to be 1. Then in the second value, instead of x, you want to substitute the value to be 1, so that you can found the value to be 1 divided by 2, that is equal to 0.5. After getting the second value, in order to get the third value, you want to substitute the x value to be 2. So you will get the value to be 0.2. Then if you substitute the value to be 3, you will get the value to be 0.1. Likewise, you can complete the tabular column by substituting the corresponding x values. After completing the tabular column, we want to use all the 3 rules one by one by using the formula. First we will see how to substitute the trapezoidal rule. The formula for trapezoidal rule we have seen already is integral 0 to 6 dx by 1 plus x square. This is the problem they have given, and the formula is h divided by 2 sum of the first and the last ordinates of y term plus 2 into sum of the remaining ordinates. Here the h value found to be 1, so 1 divided by 2 sum of the first and the last ordinates. First and the last ordinates of y column is 1 and 0.027. So the first term will become 0.27 plus 2 into sum of the remaining ordinates. Remaining ordinates in the y column is 0.5 and 0.2, 0.1, 0.05 and 0.038. You want to substitute all the remaining ordinates and you want to add those values. If you add those values, after that you want to multiply with the 2, and if you simplify this values, you will get the final value of the trapezoidal rule to be 1.410799. Likewise, you can get the trapezoidal rule. After that, when we are going for the Simpson's 1/3 rule, here the formula is given by h by 3 into sum of the first and the last ordinates plus 2 into sum of the remaining odd ordinates plus 4 into sum of the even ordinates. Here h value is 1 and you want to substitute the first and the last ordinates from the tabular column. It is found to be 1 plus 0.0270 plus 2 into the odd ordinates which we got from the tabular column is 0.2 plus 0.0588 plus 4 into the even ordinates of y which we got from the tabular column is 0.5 plus 0.1 plus 0.0384. If you simplify all these value, you can get the final result of the Simpson's 1/3 rule is 1.36617. So now you got trapezoidal rule value and Simpson's 1/3 value. After that, when we are going for the Simpson's 3/8 rule, you want to substitute the corresponding tabular values in the formula. So the formula will become 3h by 8 y0 plus y6 plus 3 into y1 plus y2 plus y4 plus y5 plus 2 into y3. When you substitute the y0 value and y6 value, you will get 1 plus 0.0270 plus 3 into y1 value, y2 value, y4 value, y5 value. You want to substitute all these values from the tabular column, and y3 also you want to take from the tabular column. After substituting all the values, if you simplify and multiply all the value with 3 by 8, you will get the final result of Simpson's 3/8 rule will be 1.35708. So now in this problem we got trapezoidal rule, Simpson's rule and Simpson's 3/8 rule. Now we just compare all the 3 values through the graph. See here, this is the comparison graph. For this given problem, the trapezoidal rule we got the solution as 1.41, and for Simpson's 1/3 rule we got the solution to be 1.366. and for Simpson's 3/8 rule the solution we got is 1.357. When we compare all these value, all these three rules, trapezoidal rule found to be the highest value and Simpson's 1/3 rule found to be the middlemost value and Simpson's 3/8 rule will found to be the least value. So for in any problem, if you want to get the accurate result, you can just concentrate on the Simpson's 1/3 rule, because when we go for the trapezoidal rule, you will get the highest value, and for Simpson's 3/8 rule, you will get the very least value. But in order to get approximate result or for the given problem, you can use the Simpson's 1/3 rule. And for the comparison, when we compare the trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule, we will get trapezoidal rule, it is a linear function, and this rule is simplest one, but it is least accurate. When we are going for the Simpson's 1/3 rule, it will be the polynomial of degree 2 and it is not a linear function, and the number of ordinates must be odd and the number of intervals must be even in Simpson's 1/3 rule. When we are going for the Simpson's 3/8 rule, this rule will contain the polynomial of degree 3 and the number of interval must be the multiple of 3. When we go for all the three methods, trapezoidal rule, it is a linear function, and Simpson's 1/3 rule, it is a polynomial of degree 2, and Simpson's 3/8 rule, it is a polynomial of degree 3. So I think through this single problem you can find the comparison of all the three rules. Now as a conclusion, we can say that to determine the numerical integration formula for the function, just we apply trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule. When we compare all the results, we found that Simpson's 1/3 rule gives the better result than any other method. That is, when compare all the three rules, if you need to get the better result means you want to go for the Simpson's 1/3 rule. This is the conclusion which we got from comparing all the three values. Now for your reference of these three rules, you can just go to this link, and so that you can able to get the clear view of all the three rules. In the next class, we will see what are the application of the numerical integration and how to get the difference equation we will see. Thank you so much.